The United States Army Transportation Corps S160 class was one of the most important wartime steam locomotive types of the 20th century, created to meet the immense logistical demands of the Second World War, and to do so under conditions in which speed of production and ease of development mattered more than refinement. These rugged 280 consolidation freight engines were intended to haul military supplies, ammunition, vehicles, fuel, engineering materials, and troops across damaged railways in active theatres of war, often over lines that had been neglected, hastily repaired, or badly damaged by bombing, sabotage, and retreating armies. Built in vast numbers between 1942 and 1945, they were designed in the United States, but operated across much of the world, including Europe, North Africa, Asia, and South America. In total, 2,120 locomotives were produced, making the S160 one of the most numerous military steam classes ever constructed. Though austere and often crude by peacetime standards, they became indispensable to Allied transport operations and later to post-war reconstruction, serving as practical workhorses at a time when many railway systems had been stretched to breaking point or physically shattered by war. The origins of the class lay in earlier American military locomotive practice. During the First World War, Baldwin had produced the famous Pershing 280s for service with Allied forces in Europe, and these engines demonstrated the value of a standardized military freight locomotive that could be shipped overseas, assembled quickly, and maintained under demanding field conditions. During the 1930s, as another major war became increasingly possible, the American military authorized updated contingency designs based on those earlier engines, producing the S159 type, and preserving the principle that, in any future conflict, railway transport would again be crucial to the movement of armies and supplies. While the United States was still neutral, President Franklin D. Roosevelt approved Lend-Lease aid that included the USATC S260 class, a Hokkaido type specifically designed for British loading gauge restrictions and intended to support wartime transport overseas. Once America entered the war in December 1941, however, the scale of the problem altered dramatically. The United States Army Transportation Corps needed a locomotive that could be built rapidly in huge numbers, shipped overseas in sections if necessary, reassembled without difficulty, and work over poor quality or war-damaged track throughout Europe and elsewhere. It also had to be adaptable enough for varying operational requirements, fuel types, and railway practices. The result was the S160, designed under the direction of Major J.W. Marsh of the Railway Branch of the Corps of Engineers, and shaped by the harsh reality that reliability in war often meant mechanical simplicity rather than sophistication. The S160 was conceived according to strict wartime austerity principles. It had to be powerful, simple, cheap to construct, and mechanically robust, rather than refined. Every major feature reflected a desire to reduce production time and conserve labour and materials, while still producing a locomotive capable of hauling heavy freight under severe conditions. Many components were simplified for rapid manufacture, and the general arrangement was intended to be straightforward both for builders and for maintenance staff, working far from the factories in which the engines had been produced. Cast steel frames were used on most locomotives, although a few had flame-cut frames from rolled steel slabs. Cast wheels were fitted, and rolled steel plates were preferred to more time-consuming castings where possible. The front two driving axles were sprung independently from the rear two, enabling the engines to cope more effectively with indifferent track and poor alignment. Though nominally a 280, this springing arrangement effectively divided the wheelbase into two groups of coupled axles, improving flexibility on rough routes and making the engines more suitable for railway systems that were operating under wartime strain. The tender was also practical in design, with an inset coal bunker above the water tank to improve rearward visibility, a feature comparable with the British WD Austerity 280, and one that was especially useful when locomotives had to run tender first over temporary or congested lines. In technical terms, the class was highly capable, even if its appearance and finish suggested something more utilitarian than elegant. The locomotives weighed approximately 72 tons 10 hundredweight, while the tenders weighed approximately 52 tons 2 hundredweight. They carried 57-inch driving wheels, outside cylinders measuring 19 inches by 26 inches, Walschaerts valve gear with piston valves, and a superheated boiler working at 225 psi. Tractive effort was around 31,490 pounds force, sufficient for heavy freight work on gradients and over long distances, particularly where trains consisted of military stores, fuel wagons, or loaded goods stock needed urgently at ports or frontline depots. The tender could carry around 8 tons of coal and 5,500 gallons of water, capacities that gave the class a useful operating range without making it excessively heavy for lines of doubtful quality. They were also designed so that they could be converted to oil firing if local fuel supplies required it, a point of real importance in overseas service where coal quality could vary sharply or oil might be easier to obtain. The boiler was mounted higher than on the earlier Pershing engines, permitting a larger firebox and greater grate area. This made the class more powerful while keeping axle load within acceptable limits for lightly laid overseas railways, and though the design was not especially advanced, it was practical, and in wartime practicality was more important than novelty. Construction was entrusted to America's three great steam locomotive manufacturers, the American Locomotive Company or ALCO, Baldwin Locomotive Works, and Lima Locomotive Works. Production began in 1942 and continued until 1945, with some later derivative construction extending beyond the war. Hundreds were completed in batches, often leaving erecting shops in long lines ready for shipment, and the scale of the program reflected the urgency with which the United States was prepared to support Allied campaigning on a global scale. The urgency of wartime demand meant quantity and speed took precedence over finish, with components having to be interchangeable between builders so that repairs could be carried out quickly overseas without waiting for parts from one specific manufacturer. This standardization was one of the great strengths of the program, since it meant that depots and workshops in Britain, North Africa, or continental Europe could keep engines in service with less concern for builder-specific variations than might have been expected in normal peacetime locomotive practice. Many locomotives were shipped through South Wales ports, assembled or prepared at Ebbw Junction Depot near Newport, and then dispersed for service, while others were sent directly to operational theatres, and many more were stored pending major Allied offensives. But in all cases, the class was treated less as a conventional railway fleet and more as a strategic transport asset. Of the total build, 800 were sent to Britain during 1942 and 1943, and officially, many were described as being present merely for running in, but in practice they were immediately absorbed into the overstretched British railway system, replacing damaged locomotives and increasing freight capacity ahead of the invasion of Normandy. The British railways by this stage of the war were under immense pressure, carrying military traffic, civilian goods, coal, food and industrial materials over a network suffering from heavy wear, deferred maintenance and enemy action. The arrival of the S160s, therefore, came at a crucial moment, and the first locomotive arrived in Britain in November 1942. The first 43 engines were sent to Doncaster Works for completion and initial operation over the East Coast Main Line, setting a pattern in which British workshops and operating departments adapted the unfamiliar American locomotives to local conditions while putting them straight into traffic. Eventually, the four main British railway companies received allocations, with 174 going to the Great Western Railway, 168 to the London and North Eastern Railway, 50 to the London, Midland and Scottish Railway, and 6 to the Southern. They worked across South Wales, East Anglia, Yorkshire, Scotland and southern England, hauling military trains, coal, goods and troop traffic. On some sections they appeared in considerable concentrations, while elsewhere they were seen more occasionally, but everywhere they represented a substantial reinforcement of motive power at a moment of genuine national need. On the London and North Eastern Railway, the class was spread across several depots, with groups allocated to places such as Woodford, March, Stratford, Heaton, Neville Hill and St Margaret's. This produced a wide geographical spread of operation, and some engines ranged far beyond their nominal home areas. The Great Western Railway, with its close connection to South Wales ports and troop movements, made especially heavy use of them in the western approaches to the invasion build-up. The Southern Railway, despite receiving only 6 examples, had particular reason to value additional freight power because of the strategic importance of South Coast and Southeastern routes handling troop concentrations, stores and invasion traffic. The London, Midland and Scottish Railway similarly found them useful in relieving pressure on an overworked wartime locomotive fleet, and although the fiction of running in remained convenient administratively, there was never much doubt that these American engines were there to do real work, and they did so in prodigious quantities. British crews found the locomotives powerful but unfamiliar. As they were right-hand drive on railways where left-hand drive was more common, the controls differed from British practice, and the braking performance was inferior by local standards. A Westinghouse steam brake was fitted to the locomotive itself, but response times were poor because of the distance between the driver's valve and the brake cylinder, making the class feel less sure-footed and less confidence-inspiring than contemporary British freight engines. Axle box grease lubricators also proved troublesome, as if servicing lapsed, hot axle boxes became common, and wartime conditions made ideal maintenance difficult to guarantee. Crews used to British locomotives often regarded the S160 as rough riding and mechanically noisy, and some disliked its general layout, especially where visibility, cab comfort and familiar fittings were concerned. The greatest problem, however, lay in the water gauge arrangement, as instead of the more familiar British pattern, a single Klinger-type gauge was fitted. If handled incorrectly, it could trap water and show a false level, and several crews were misled into believing sufficient water remained in the boiler, when in fact levels were dangerously low. Within 10 months, 3 British-based S160s suffered firebox crown collapses, and the first serious incident involving locomotive 2403 in November 1943 killed a Great Western Railway fireman. Further explosions involved number 2363 at Thurston in January 1944 and 1707 in South Harrow Tunnel later that year, with these incidents giving the class a difficult reputation in some quarters and demonstrated the risks that arose when unfamiliar equipment met hard wartime service and hurried maintenance. Despite this, however, the S160 was not designed for elegance, longevity, or crew comfort, and with it being designed to win a war by moving huge volumes of traffic under appalling conditions, the class most definitely succeeded in that task. As preparations for the Normandy landings intensified, a second batch of 400 engines was stored in South Wales ready for deployment to France, with these locomotives being effectively held in reserve for the moment when Allied forces broke back into Western Europe and required an immediate supply of railway motive power on the far side of the Channel. After D-Day, locomotives were gathered from British Railways, refurbished at Ebbw Junction and shipped across the Channel, with many then entering traffic behind advancing Allied armies, hauling supplies through liberated France, Belgium, the Netherlands and Germany. Others had seen service in Operation Torch, where they accompanied American forces under General George S. Patton across Algeria, Morocco and Tunisia, before many moved onwards to Italy. Their work was unglamorous but essential, as the armies could only advance if ammunition, food, spare parts, fuel, bridging materials and reinforcements followed them, and the S160 was one of the principal means by which such supplies could reach the front. In continental Europe, the class became closely associated with military railway operations during the Liberation Campaign, as with the railways of France and the Low Countries having been damaged by years of occupation, sabotage and bombardment, the Allied advance meant they had to repair routes almost as quickly as ground forces moved forward. The S160s, with their ability to work on poor track and their standardized components, were well suited to this environment, and they hauled trains from ports and depots inland, linked newly restored railway sections, and served the constant stream of traffic that sustained the Allied armies after June 1944. Some locomotives were lost in transit, however, including examples sunk at sea when German U-boats attacked shipping carrying them across the Atlantic. After the war, the class entered a second and often longer career in civilian railway service. Europe's railways had been devastated, and surplus S160s provided an immediate answer. For many national railway systems, these locomotives were not merely useful extras, but an emergency replacement fleet that allowed regular freight and mixed traffic services to resume, while domestic locomotive production recovered. Large fleets were sold or transferred abroad, with Hungary receiving 510 examples as the MAV Class 411, of which 484 entered service, while others were cannibalized for spare parts. Italy absorbed 244 as the FS Class 736, plus 4 salvaged from a sunken ship, and there the class became a familiar post-war freight locomotive, with many being oil-fired. Poland received 575 locomotives as classes TR 201 and 203, and in Polish service some were modified with local fittings including different valves, electric lighting and cab alterations. Czechoslovakia took 80 as the Class 4561, Austria had 30 as the OBB Class 956, Yugoslavia received 80 as the Class 37, Greece obtained 27 initially and later another 25 from Italy, Turkey operated 50 examples, and smaller allocations went to France, Germany and Spain, and in many of these countries, the S160 served not merely for a few years of emergency use, but for long periods, and in some cases into the 1960s, 70s and beyond. The overseas story of the class was not confined to Europe, as in North Africa, the locomotives had already proved useful in supporting military operations under harsh climatic conditions, with dust, heat and difficult infrastructure adding to the unusual demand of wartime running. In the Soviet Union, broad-gauge derivatives designated Class Shah were supplied, some later working on Sakhalin, while other broad-gauge variants were constructed for India. In Asia, China received numerous locomotives as KD6 class, many heavily modified in later years with altered cabs, revised fittings, and, in some cases, dramatic external changes that reflected local rebuilding practice and long industrial use. South Korea obtained 100 examples, while North Korea also operated S160s obtained via Soviet and Chinese sources, resulting in the curious situation of both sides using the same American wartime design during the Korean War. India received 60 broad-gauge kit-built variants known as the Class AWC, assembled locally and still in service into the late 1970s, a remarkable lifespan for locomotives conceived as wartime stopgaps. A few examples also worked in the Americas, with some remaining in US military use, while several later worked on the Alaska Railroad, whose severe climate and long freight hauls gave them a new but demanding environment in which to operate. 2 similar locomotives reached Peru, and a small batch related to the design was supplied to Mexico. One of the more interesting aspects of the class is that even its designation is not entirely straightforward. Although S160 has long been the accepted and familiar name, it may never have been a fully formal official class title in the way later enthusiasts often assume. Surviving drawing indexes and engineering records do not always use the term, and Baldwin's own internal designation for the design was different. Nevertheless, S160 became established in railway literature and preservation circles, and is now inseparable from the class's identity. Today, at least 26 examples survive in preservation, making the class one of the best represented mainline steam types in existence. Several have been repatriated to Britain, where engines such as 6046, 5197, 5820 and 3278 have worked on heritage railways and have become popular representatives of the American wartime presence on British metals. Others survive in museums or static display in Europe, the United States and Asia, while a few remain in poor condition, serving as parts sources or awaiting restoration. In the end, the USATC S160 class was never elegant, and it was certainly not free from defects, but it was one of the defining railway machines of the Second World War, being designed under immense pressure, built in extraordinary numbers, and sent wherever the Allied cause required motive power, with these locomotives carrying the burden of war and then helping to rebuild shattered nations afterwards. Few steam locomotive classes can claim to have served on so many fronts, under so many flags, and in such a wide range of climates and railway systems, and their story is not simply one of engineering, but of global conflict, industrial urgency, and post-war recovery. Their continued survival in preservation ensures that this remarkable chapter of railway and military history remains vividly remembered, not only as a tale of machinery, but as part of the wider story of how rail transport sustained armies, restored trade, and helped to reconnect a broken world.